Good morning to everyone. In today's video, we are going to see a numerical to solve the primary constant by using your secondary constants. Already we know the relation between your primary and secondary constants which we derived in our previous classes. So we have the characteristic impedance, propagation constant, attenuation constant and phase constant in terms of primary constants. Right now, by using those relations, we are supposed to find out what will be your primary constants. So first of all, we'll look at the problem, what they mention. So they mention that a transmission line has a characteristic impedance of 710 angle minus 16 degrees at 1 kilohertz frequency. So at the same frequency, they provided the attenuation constant as 0.01 nefers. And phase constant as 0.035 radians per kilometer. Okay, per kilometer they mention. So right now you supposed to find out your primary constants per kilometer. Okay, so first of all we just simply written the data whatever they provided. So they provided Z0, alpha, beta and frequency f. So as we know that, so propagation constant, okay, propagation constant gamma is nothing but equals to your alpha plus j beta. So already we know that alpha and j beta. So from this we find out what will be your propagation constant. Okay, we find out what will be your propagation constant. So please observe here, the formulas is very simple, but the only complicated thing is we have to consider this because they will be provided in terms of, because per kilometer the value is very minute, so we have to take care while solving the problem. Okay, so here it is 0.01 and here it is 0.035. So to make it common, to take out the common element 10 power minus 3, I am just making this one as 10 and this one is 0.035. Then it becomes, when you take this one as 10 power minus 3 common, it becomes 35. So I've just find out the what will be the modulus. Okay, what will be the phase, polar format of this rectangular thing. Okay, polar format of this rectangular thing. We supposed to find out what will be the modulus of gamma and angle of gamma. So modulus of gamma we already seen, square root of real value plus imaginary value. Square root of real value is nothing but 10 square plus 35 square. So 10 square plus 35 square square root of your answer will be equals to 36.40. I just common out 10 power minus 3. For this value also the square is there. I just simply take out this one outside, so it will become 10 power minus 3. So it will be 0.036 or we simply given it as 36.4 into 10 power minus 3. And what about your angle? So angle equal tan inverse is nothing but beta divided by imaginary value divided by real value. So imaginary value 0.035 divided by 0.01. So it will be 3.5. So 3.5 tan inverse of shift tan inverse 3.5 will be equals to your 74.05. Obviously it is above the value, we can simply give it as 74.1. so there will not be any issue. Okay, so we find out what will be your gamma. We know the values. For Z0 we represented square root of Z1 divided by Z2, and for gamma we represented square root of Z1 into Z2. So if you multiply these two, the denominator thing will be cancelled over. G plus j omega c will be cancelled over. So the numerator itself square root of Z1 into square root of Z1. It will be square root of Z1. So z naught gamma, if you multiply these two things, the resultant answer will be equals to r plus j omega L. Because why we multiply these two things, I know what is the z naught and I know what is the gamma. So I multiply these two things and find out what will be your r plus j omega L. So r plus j omega L is nothing but z naught value multiplied by your gamma value. So if I want to multiply, I already stated these points many times. If you want to multiply two polar quantities or two rectangular quantities, for multiplication, instead of going with the rectangular, polar will be the best solution. So whatever the magnitude is there, we simply multiply those things. Whatever the angles are there, we simply add up the things. So here 36.4 into 10 power minus 3, you can write it later. 710 multiplied with 10 power minus 3, it will be around 25.5844. And what about the angle? 74.1 plus, oh sorry, it will be minus 16, minus 16, it is around 58.1. So whatever this r plus j omega L, it is given as 25.84 angle 58.1. So now we supposed to convert this polar into rectangular format. So I know the magnitude, I know the angle. So I simply apply these things to find out what will be the r plus j omega L. So simply apply these things and find out the value. Required quantity is 25.844, okay, 844, and cos of 58.1, 58.1, 13.65. Now I require the same thing for sine. So I no need to change the entire thing. So simply I just delete this cos. In place of cos, I just provided the sine. 21.93. So above the 5, I just added 1. So here it get r equals to 13.65 and L as, please understand this. This is not direct L. J omega L is equals to J 21.94. So now I have to convert, find out what will be the inductance L value itself. Okay. So J will be cancelled over on both sides. J will be cancelled over on both sides. When coming to the omega L, omega will be given as 2 pi f, and here f is nothing but your frequency 1 kilohertz. So I just take it out this for denominator. So 2 into 3.14 into 10 power 3 kilo. So I'm not modifying this kilo to make it as in milli. So 21.94 divided by 2 into 3.14. Okay. So it will get as around 3.49 millihenry per kilometer. Right now we've calculated what is the R and what is L. So the same process will be repeated to calculate your G and C. So when you multiply Z0 and omega, Z0 into gamma, we are able to find out what will be your R and L. The same thing, if I divide these two things, the numerators r plus j omega will be cancelled over to each other, and the leftover element is g plus j omega c. So for that reason, instead of multiplying, already we multiplied, right now we are going to do for the division. So z0 divided by gamma. So if I divide this value this value will be cancel over to each other, and the rest of the denominator is 1 divided by g plus j omega c. Okay, I know the z0 value, I know the gamma value. If I if I furtherly go the same process, I need to rationalize the elements, I need to find out the magnitudes, all the things. So instead of that, okay, I know z0 divided by gamma, 710 angle of, so instead of doing this, okay, if I reciprocal this, okay, if I reciprocal this, so don't worry, we are doing the same thing. 36.4 divided by 710 multiplied with 10 power minus 3. You are getting it as around 5.126 into 10 power minus 5. So that we just simply reciprocal this. In the same way, the angles. So angles is 74.1 minus of minus plus 90. Sorry, plus 60. It is around 90.1. Okay, so now again the same process, we have to elaborate this one to convert into rectangular format. So real value, for real value we are going for the cos terms, and for imaginary values we go for the sin terms. So cos 90 nothing but it is will be approximately, almost 0. 90.1 is nothing but 90, so approximately equals to 0, and whatever your imaginary terms, sin 90 equals to 1. So from this we are supposed to find out what will be your g will be equals to 0. Okay, what about your c? So 5.126 into 10 power minus 5 divided by your omega value will be equals to 2 pi f. So we know 2.314 into 10 power 3. So you can find out your capacitance. This is the way how you are supposed to find out the primary constants for the given secondary constants. Okay, thank you.